In this picture, you basically see the interactions that exist between the elementary particles, both the particles that make things be the way they are and the particles which make them react the way they do. In other words, the fundamental constituent particles and the fundamental force carriers. Now, notice, for example, that the Higgs boson will affect anything that has mass, and therefore all the Z and W bosons which mediate the weak interactions, as well as the leptons and fermions which have mass, are going to be affected by the existence of the Higgs boson. And theoretically, the Higgs boson may affect itself, and which means it would have mass, or would have a presence in the universe. And then theoretically, that's actually what creates some of that dark matter that's currently indetectable, that we have not yet figured out how to detect. It's not that it's not there, it's just that we haven't how to find a way to actually detect its presence. And some of it may be the actual Higgs boson particles. Now, the photons, because they don't have mass, they're not going to be affected by the Higgs boson. But they do interact with both leptons and quarks and give energy or take energy away from those leptons and quarks, and they're also going to be interacting with anything that has a charge, and that's why they're also interacting with them, because those things have charges, including the plus or minus W bosons, which have charges. And so you're going to have interaction with the photons there. And remember also, when weak interactions take place and decay actually happens, you're going to release photons. When leptons go through a state of lower energy to higher energy, you release photons or absorb photons. And you're also going to have the same thing happen with quarks when they interact with each other. You also have the gluons, and the gluons are the particles which will hold together the quarks and basically create those color charges. They have everything to do with the strong interactions. Kind of analogous to the electromagnetic charges that photons create, but more like, a different kind of reaction that has its own properties and everything. And gluons actually give gluons themselves color. So they give themselves color, and they give color to the quarks themselves as well. And the color interactions that they create actually generate the connection that exists between the quarks. You can think of what holds quarks together as basically quarks donating and receiving gluons from each other. So they're playing coloring with the world. And then you also have the Z boson, which is another one of those bosons that mediates the weak interactions. And because they don't have a charge, they're not going to be involved with the photon, but they will be involved with the other particles, including quarks and leptons. And so that shows you all the relationships that can possibly exist between the particles of the standard model of particle physics.